Hi, everybody. So by way of introduction, hi, I'm David Anstiss. I'm delighted to be able to talk to you today. Just a little bit about me quickly before we jump into the thing and who I work for. So I've worked in the telecommunications space for 22 years, mainly mobile, 5 years with Voda, 8 years with Ericsson, specialized in mobile packet core. Then I transitioned and pivoted slightly into location and DPI. Worked for a DPI company for a few years. And then 6 years ago, I got my dream job. I actually started working for SS8. Now, SS8 is a lawful intelligence company. We provide capabilities into both agencies, law enforcement, and CSP communities around the world. And what our job is to do is to help provide regulatory compliance. So we give people the technology needed to be able to intercept relevant communications that are lawfully warranted within the network. So what I'll do now is I'll give you a quick view of the agenda of what I'm hoping to cover off today. I'm going to sort of pitch this as more of an executive overview, and I'm going to do a little bit of deep dive in a couple of places just so you can understand the fundamentals under what we're doing. So I'll give you a quick overview of the end-to-end LI space, introduce some of the changes that have happened and the impact that that's had on LI, but I'll also bring some real-world answers to those questions and some of the stuff that we've had to do as a community to be able to mitigate the challenges, and even if they're incremental steps, actually apply that to the community so that law enforcement can get the data off and help protect people. Another on vogue topic is the Suki correlation. So one of the big things that's preventing rollout, formal rollout in certain countries, is the fact that people can no longer use IMSI grabbers. They can't identify people locally. And that is actually making the government prevent true 5G core rollouts in certain countries, especially in the Latin American region where we work. So I'll touch on that as well and what we've been doing with certain government agencies to do to mitigate that risk, and what we've been doing with the standards bodies again to do that. I'll give a quick summary of what we've experienced in 5G, the reality versus what we actually expected, and that might give you some insights as well. And then obviously I'll open the floor to questions at the end. I prefer to be an interactive session, but I think the way this will work best if we just take the questions at the end. If there's anything there, please fire them at me. Anything we can't answer today, happily take away and come back to you on. Okay, so we've got 20 minutes, let's make a start. So what is lawful intelligence? Well, first of all, you have devices and networks all around the world, and you have a community that needs to be protected. So in law enforcement, the first thing you have is something called mediation. Now, mediation is a way of taking data out of a network and correctly formatting it for a law enforcement agency to analyze and extract intelligence from, be it listening to a phone call or be it reconstructing an MMS or a web page. Now, the key thing with law enforcement and mediation is it's country specific. A lot of countries will sort of tweak it. So as much as it forms a particular standard, may it be ETSI or 3GPP, we have the ability to ingest that and change it to the relevant standard needed for LIAs. Now, there's two ways of getting data off of a network. You can talk directly to the network equipment vendors, the Nokias, the Ericssons, the Samsungs, and you can provision target lists in there, and you can take data off of that for mediation and delivery. The second method is with passive probes or sensor technology, whereby you listen to optical links and you can extract stuff, removing the relevant headers and that, and target devices that way. A lot of countries prefer that method because it's completely enclosed and completely at their control, so nobody knows what they're looking at and what they're doing. The challenge with 5G is with the encryption and obviously being cloud native, these problems are not possible to be able to actually passively monitor with sensor technology. So the other part of lawful intelligence, you have data retention. You've probably heard of that before. That's your comms data records, whereby you store CDRs, so you understand what the network's doing and what the information is about phones and devices. And that gives you a historical log, whereas lawful interception tends to be real time with a warrant for a particular target or group of targets. Data retention is over and above that. That does like historical records, but it doesn't give you the level of detail. But it's also a very useful tool in the arsenal. Final thing we have is location intelligence. Now, this can be done passively for mass intelligence gathering, or it can be done targeted by GMLCs. Now, the location we get at the moment in 2G, 3G and 4G is a little coarse. You can extract data from phones that give you a bit more accuracy. But with 5G, I'll touch on this as well. The location enhancements that we're getting and we're seeing in the real world is absolutely amazing. You're actually not just getting the X and Y axis, you're also getting the Z axis. So you can actually horizontally place people within buildings. The final part I'll touch on is open source intelligence. So my company's based in Silicon Valley. I work out the UK office, although I'm in the US at the moment. The US, we have a great interaction with different carriers, so and also with the over-the-top operators, Facebook, Apple, Netflix, and Google. And one of the things we're doing is cloud network, and that's obviously very important to be able to take data from the over-the-top providers as well. And that's something that's going to come through to the CSP community. The final part of the puzzle is the actual monitoring suites that intelligence agencies use. So these provide the traditional over-the-shoulder reconstruction where they can play back voice, they can look at basic data and reconstruction, but it also has some advanced features, big data analytics, being able to look at all the data that's coming through from 5G networks and the challenges that's posing. And also you have advanced mapping capabilities within the suite. So you're able to do geotagging, you're able to geofence people and watch and plot how they're moving around and build pattern of life around what they do. So that's kind of the very basics of what lawful intelligence is. So now what I'll do, I'll move you into what the changes we're seeing in 5G are and how that's impacting us. So there's 4 real tranches of work that I'll focus on a little bit today. The performance. Now there's been some key things that have happened already in this field, and I'm going to touch on what the challenges were, how we've addressed the challenges in the interim, and what the end result for those challenges are. Ultra low latency is also important. That sort of ties very nicely in with MEC and cloud native stuff, and the fact that your packet processors and UDFs and the like are actually going to the edge. And so the ability to actually provide law enforcement at the edge as well as in the core is now fundamentally important, and it's something we have to look at. High throughput is causing us a headache, and as I say, I'll touch on that in more detail shortly. New network elements, new target identifiers, the fact your IMEI is gone, you've now got a permanent equipment identifier, your SUPI and the way that transmits and the encryption that provides is a real headache for, as I say, the cell site simulators and the like. And then we get in touch on the enhanced location, the smaller cells. We're not seeing as much of this yet. The MIMO cell, the RAN seems to be a little slower. They've done the macro cells or the larger cells, but as the micros and the MIMOs are coming online, we're getting better and better location data. And as I say, with the power and the information we're receiving from those networks, we're actually now able to start plotting it in the Z axis. So whereas before you had a 2D map location, you're now actually able to move into a 3D map location. So I'm quite conscious of time, so I'll move on quickly. Right, so 5G now requires new LI specifications. Now, I know these charts can look a little bit overwhelming. The key thing I want to get out of here is 2 or 3 things. 2G, 3G, and 4G, there were no real changes. There was very minor ones, but nothing really there. With 5G, we have changed a lot of stuff. Other than the new network elements and the new naming conventions and the new things, there's 3 things to take away. We've reused a lot of the same standards, but they have actually developed 3 new parts, including requirements, architecture, and implementation. There was a lot of reuse of the transport. So HI2 and HI3 refer to the handover interfaces. So this is where your intercept related information and your core content is delivered from the network to a law enforcement agency. That has remained mostly the same, but there is a fundamental change in it. And one of the things is the PDU structure has changed, and that requires both the LI and LEMF systems to be upgraded just to be able to process the data. So if we step into the new 5G requirements for interfaces, again, a bit of a complex diagram, but I'll talk briefly on this one. You have new things that are coming in. So you've always had a traditional X1, X2, X3, which would be your provisioning interface and your IRI and CC handover. But there's actually 4 new interfaces that you should be aware of in this one. The first is X0, the internal 0 interface. Now, what this does is this talks between the mediation system and the network element, and it establishes trust. Because all the true 5G core networks are virtualized, you have to be able to establish trust that the network element is who it says it is, and establish an encrypted bearer before you can then provision the information and target data to that network element. The second is a HI3A. So this is about the CCPAG, or the communication content of interception aggregator. So what this basically is your edge packet processor. So this can be deployed either centrally or wherever you have a packet access for edge. This thing needs to be deployed as well. So this needs to be a virtual application that can be spun up unless you're going to have static edge network elements, and we're finding that more and more. HI4 is a new interface for handover. This gives dedicated login, logout information for the system. And probably the most interesting is going to be the LIS1 information. Now, one of the things that comes with 5G networks is multiple IoT devices. So we're going to see a transition gradually, and I think we're starting to see it now. At the moment, you've got connected homes. So you've got home router, and you've got a smart fridge, you've got light bulbs, everything that's connected to your home is going to transition eventually to a low-powered IoT connection. And that will mean that when subscribers take out a mobile contract, you're no longer going to get just your mobile phone or your smartwatch connected to that account. You're also going to get a package that allows you to connect your fridge, freezer, Hoover, everything to your IoT device. And we'll kind of do away with the broadband connection that you had traditionally, and everything will be done over the 5G network. And what we are finding is more and more that you need to be able to literally provision one thing or one target identifier, but be able to get all the data for that person, despite the collateral intrusion that they may occur. So if they've got that as part of their account, you need to be aware of it. So now let's talk a little bit about some of the challenges we've seen. So one of the things that we have with 5G is TCP transport. Now, I'm going to show my age here. So when I started, the tax systems in 1G were coming out, and GSM was just being delivered. So I was there when GPRS and Edge first came about and wireless application protocol was first delivered. So as I've been through the technology, you've seen data rates gradually increase and performance improve. Now, one of the key challenges we have here is LI never moved with those changes. So when they first established a connection with a network element, you only had to have a single TCP socket and connection socket. And that was fine because the traffic never exceeded 1 gigabit for a target. So you're able to hand that data over, no problem, to your mediation, format it correctly and deliver it. The challenge we have now is that with theoretical data limits, we actually see about 1.2 gig is actual real. You can only hand over a certain amount of data, but for comfort, we'll say 1 gig. With 5G in the field, and we have 5 live 5G deployments globally, one of which we've had 7.5 gig handover as a demo in the real world. So 7.5 gigabits per second, you're never going to be able to deal with that. So one of the ways you could address it would be changing TCP connections to UDP connections. We looked at that. The problem is it's lossy. You get no guarantee that the data is being delivered. So one of the things that we worked on with Cisco and published with 3GPP as part of the standard was the ability to have a multi-socketed TCP connection. So you could basically establish an N+1, maybe 10 or so, for delivery to the mediation. The challenge you then had was delivering that data from the mediation solution to the law enforcement community, and the fact that you had to mirror that capability with them and then allow them to ingest that data. Now, one of the things we find with CSPs are they've got funding, they can move forward with cutting edge technology. Law enforcement can't always meet that obligation. So they often have a 7 or 6 year tie-in for their infrastructure. So they can't necessarily accept that amount of data. So one of the things we were asked to do, and has been well documented now, first in 3GPP and then later in NC, was PDHR. So what's PDHR? So what you get in your network traffic is a lot of encrypted video streaming. So you can identify that traffic, and effectively, you don't necessarily need to send all that over. If somebody's watching a 4K video, you don't want to send that to the agents necessarily to look at. So what you can do is take that data, and rather than deliver it or content of that data, you can create a summary report and just deliver the summary report every 30 seconds or a minute, depending on your chosen obligation. And you're then able to just discard the actual content itself because you've given a summary report of all the metadata. So you're effectively reducing quite a lot of bandwidth. The second option is to actually retain that data and then deliver it on demand if the LMF or the analysts in law enforcement want that data. And then after a certain retention period, you can just discard it. So what are we seeing in the real world? Well, I've reflected this based on Cisco's last report that about 80% of consumer internet is going to be video. We're not quite seeing that at the moment. Truth be told, we're seeing about 60% reduction where we're deploying this capability, but it is a real lifesaver for the law enforcement guys because they're not having to handle this big tsunami of data that's being sent by 5G technology. So I think we're doing quite well for time, so I think we've got 5 minutes left, so let's jump on to the next one. Impact of 5GC on subscriber identity. Right, so this is where we have IMSI grabbers or cell site simulators. So a cell site simulator or an IMSI grabber is something that slightly more tactical that our agency friends use, and it's used to identify people and local devices or locate a device specifically and be able to find them. And the way that does is it replicates the network that's around it, and it's able to get the IMSI information. Now, one of the key challenges that we find is that subscribers' identity with a 5GC core is not transferred. The SUPI, which is the replacement for the IMSI, is only ever transmitted as a SUKI. So it basically defeats the objective. So whenever a cell site simulator is there, it sees a 2 or 3 minute leased SUKI that never repeats. So it's impossible for a cell site simulator to be able to capture network data and be able to therefore, with that information, identify the targets or where those targets necessarily are. So there's 2 methods of fixing this. You've got to be able to correlate a SUPI to a SUKI, and there's 2 different thoughts of how to do that. Now we're working, we were commissioned by the federal government to do the 3GPP method, and we've got a POC currently running on that one at the moment. And ETSI have gone a slightly different way with a different network element, but we found that both approaches have value, and we think they're both going to work. So we're very keen to stay abreast of that, and obviously deliver what's needed to the CSPs so that they can meet their compliance obligations with the LEAs when they have a need to be able to do this functionality. Okay. So let's give you a flavour of what we've actually seen and where we're going from there. So expectations and the challenges of 5G versus the reality. And let's build it out a bit quicker. So increased performance, yep, we've seen that, and we have seen some challenges around that. And as I said before, we're seeing 7.5 gig a second handover, and we've had to move to multi-TCP content delivery. New network elements have been fun and games to deploy and bring out. We also have now I call it IPHR here, IP packet header reporting. It's or PDHR as it is in 3GPP. The 2 different standards call it slightly different names, so just be careful if ever you get asked the same question. Low power IoT devices, we are seeing a ramp up in that now. More and more smart connected homes, more and more connected devices. And again, that's causing a challenge. There are some benefits to 5G that are actually really helping us, and the location, as I mentioned, is one of those. The ability to actually get the Z location is really fundamentally key to us now. Security and encryption, again, that's caused, it's a good thing, but it's causing problems at the same time. Now, cloud native, now I'll touch on this a little bit more, I'll spend a little bit more time on this one. What we're finding at the moment is that we've got smaller carriers are doing true cloud native deployments, so completely AWS, one of them, another one is a private cloud, and completely everything at where line. The challenge we have is that the regulatory compliance and the agencies that control this aren't necessarily happy for all that information to be cloud hosted. So we're finding with some of the bigger tier 1 carriers, they're doing a hybrid approach whereby they're doing certain aspects within the cloud environment, i.e. the packet processors or CCPAGs, but they actually have a hybrid watchtower whereby they have a secure, locked, racked servers that are dedicated just purely for the process of that line. And they hold the more sensitive information, the target lists and the established connections. So you have a sort of a hybrid approach. And I think that's the way a lot of people are going to go, because we have had, from our work with the law enforcement and agencies, they have expressed concerns around different attack vectors and the fact that placing everything in a cloud environment could open yourself up to potential state-sponsored actors and different risks. Again, we mentioned the regulatory compliance and the standards and about our denser networks haven't quite reached us yet, but they're getting there, and that just brings improvements in location. And finally, I'll just touch on the new interfaces and the fact that HI4 and X0 has been deployed, and the information that comes with those is really key. Okay, I think that's my 20 minutes up. So I guess I'll move to questions.
Well, thank you for that, David. And we do have a question from the floor. The question is, if you're not working with the raw data as LEA, and if you're using a summary of information, is that still valid as evidence in a court of law?
Great question. Yes. So in the deployments we've done, it is controlled by the law enforcement agency. The deployments that we have in the countries where we have deployed this, they do, this particular country in question, legislation allows for that functionality to be deployed. So when they give the summary report, it has to meet certain standards and to be able to deliver it. So yes, it has been approved in one country that I know of for definite. The second country delivers it, but I don't know that they use LI as a evidential tool in the second country. But the first country, yes, it definitely does. And I'd be happy to take that further offline if the person would like.
Okay, well, we'll leave you to do that when your session ends. I'm also wondering about hang on, I've got another question from the floor here. How will LI solutions scale as network nodes scale when traffic increases or decreases for a period of time? So
fantastic. Yeah.
How's the correlation between the target node and LI work?
So the way we actually scale it at the moment is we've got and other vendors are obviously the same. We have a cloud native application that scales horizontally. So using Helm charts, and we use Kubernetes and Docker containers to be able to establish this. And we can basically spin up as required horizontally to match as the person's traffic meets a threshold within the network element. We actually monitor that, and if it hits a 60% threshold, we spin up a new instance and establish a new TCP connection there. So it's one of those. I'd love to whiteboard and explain a bit more, but I don't have that facility here. But that's
you're free to continue in the Q&A channel if you wish after your session is ended.
Sure.
And I was going to ask you about is there an additional danger at the edge of interception? Have we opened up a new front there?
We have, and that's one of the things we are seeing. I mean, one of the carriers, and I won't name the country, but they're a big carrier, over 120 million subscribers. They are pushing everything to the edge, and that's why it kind of forced our hands to make our stuff virtual as quickly as we did. So they are moving a lot of packet processing to the edge. So you have to do that locally to where the UPF or the edge packet processor is, to be able to grab that data to then be able to fire that back into the community.
Okay. We have another question from the floor. So many users use a hybrid model of 4G/5G and Wi-Fi. So does this mean that Wi-Fi networks have no LI requirement?
They do, but the way that so good question. So if we're talking about voice over Wi-Fi calls, they use something called an EPDG that connects in via an SWU interface into a mobile packet core GGSN, and you can normally target on the not the S2A or the GGSN itself. So you can actually extract data from the GGSN for voice over Wi-Fi calls, depending if it's trusted or untrusted networks. Wi-Fi networks do have an importance, but it depends on the logging data. Now, there is a challenge with certain with newer mobile phones now. If it's an untrusted Wi-Fi service, I go into the Hilton like I'm in at the moment, and I jump on their Wi-Fi. If I don't use a login page, I just use my MAC address to log in. My MAC address is randomized, so there's no way of doing the correlation, and no easy way of doing the correlation within the core network. Now, if I have a login page, you can log that detail for the Wi-Fi stuff. As I say, for calls over Wi-Fi, because it routes through into a mobile core network, you can get the audio calls normally. I agree that if you were talking about over-the-top applications, there could be a challenge there for a WhatsApp call or another type of call. But in layman's terms, depending on the Wi-Fi network, and if it's a trusted or untrusted one, has a different application within compliance. In an ideal world, we would be able to capture any kind of data on any kind of network, but sometimes we have to take that there are certain risks that we can't do that. But yeah, definitely for calls, the way they're routed back into the network, home network, we can grab them. And depending on the ISP and how the Wi-Fi network is created, we can grab some of the information, but depends, I guess, on the deployment.
Okay, and briefly, if you wouldn't mind, because I'm afraid we're just about out of time, David.
Sure.
But do you have a view to location? Do you have a view to location accuracy and whether it's achievable in 5G?
So that's a great question. So my details up there in case people wanted to chat. So so location accuracy in 5G. Wow, it is a game changer. So at the moment, you get quite coarse data in 3G and 4G. You kind of get cell tower informations. With the RSSID, you can kind of get a power band and you can kind of triangulate it a bit better, but you're still talking up to hundreds of meters. It's not great. Assisted GPS can be better if you get malware on a phone, or there's other ways of extracting that location information. But with 5G, the information that gives us is really, and it's really starting to prove fruitful in our testing, is you're getting enhanced location cells because of just the cells are so much smaller. So you're getting that bit more. It's a bit more like a Wi-Fi network in some ways, because you're sort of 25 meters or so. And then the power levels as well, with a few other vectors that one of my location expert colleagues could talk to you for days about. Basically allows us to then plot within a building roughly where they are. So yeah, 3D mapping is a real thing that we're looking into at the moment. So yeah, location's a great one.
Thank you, David. That was great.
Thank you.